We're going to go through the rest of the problems here in the Chapter 1 practice test. So in number 9, we're given this function, and we're told that it's 1-to-1. And if we remember, all that means is that when you find the inverse by switching the input and the output, the result will still be a function. So in this case, now that we know that, it says find and simplify an equation for its inverse and check your answer, and then state the domain and range for both f and f inverse. So just one at a time here. Equation for the inverse. First thing as I do is I switch the input and the output. So x is equal to y cubed plus 2. And now we solve that for this new y. So x minus 2 equals y cubed. Cube root of x minus 2 equals y. And that is f inverse of x. Now, to check my answer, one of the things that we talked about in class is that f of f inverse of x should always equal x, because when you switch the input and output and then you make that composition, you just have this sort of undoing relationship where because if I put in something here, if I put in 5 here and it outputs 7, well then that output of 7 becomes the input of x, or the input of f, which then gives me an output. And that output is the same as the input for the inverse, because that's the definition of the inverse. The input and the output are switched. So I'm just checking to see if f inverse of f inverse of x is x. And so I'll just do the algebra here. So this is, originally I have x cubed plus 2, so I'm going to put this function into that x. So I'm going to have the cube root of x minus 2 cubed plus 2. And hopefully right away I can see that, yeah, this is going to work. First of all, the cubed and the cube root are going to cancel out. And then the minus 2 and the plus 2 cancels out. And we just get x. So we're happy. Now, for the domain and the range, I always like to make myself a little table just to kind of help remember here a nice pattern. Domain is usually easier to deal with. And so if I find the domain of each of these, because again, domain is usually easier to deal with, I'm just looking for what input values would be undefined in terms of their output. And because this function has no variables in the denominator, so nothing I put in is going to make the denominator 0. It has no even roots, so I'm not going to have to worry about I, or imaginary numbers. And it has no logarithms. There's no reason that I can't put anything I want in here. So that is in fact the domain, all real numbers. I'm going to write it as an interval of from negative infinity to positive infinity there. And then sticking with the theme that the domain is easier, if I do the domain of f inverse next, I'm looking for those same things. Zeros in the denominator, even roots of negatives, and logarithms. Well, I don't, again, have any variables in the denominator. This is an odd root, so that's okay. I'm not going to get anything imaginary out of that. And there's no logarithms here. So again, there's nothing to worry about, so my domain is again all real numbers, or the interval from negative infinity to positive infinity. And then for the range, it's just a matter of remembering the relationship between the original function and the inverse. The first thing we do is we switch our inputs and our outputs. We switch our x's and our y's. My domain is the rule for all the x's that this function gets. So whatever's true about the x's on the original must be true about the y's on the inverse. whatever's true about the x's on the inverse must be true about the y's on the original. So in this case, it's just all real numbers. It won't always be quite that friendly, but this time it is. All right, number 10. This is the one that typically gives people the most trouble. I'm going to do my best with the graphing here on my sort of cheap stylus, sorry. So part A, well, first of all, this is the graph of f, and we're given the equation for g. Part A says sketch the graph of h of x that is f of x plus g of x. Now remember that all that means is for any given input, say I want to know h of 0. H of 0 will just be f of 0 plus g of 0. Well, f of 0, I can tell from the graph, seems to be negative 4. And g of 0, I can plug into the equation. 2 times 0 is 0, plus 2 is 2. And so I'm going to get negative 2 here. So I have the point 0, which I inputted, negative 2, which was finally output there. And I'll just do this for a couple of points. I'll write it out, why not? Let's do h of 2 should be f of 2 plus g of 2. F of 2 is 0. G of 2 is 6. We'll do negative 2 as well. F of negative 2 plus g of negative 2. F of negative 2 is 0 again, that's why I picked it. And g of negative 2 is negative 2. So that is negative 2 here. Now, right here, I'm kind of wondering, I'm thinking, all right, this is strange. I've got this, these both seem to be at negative 2. And is it just going to be a horizontal line between them? I'm not sure. So this tells me I'm not quite sure how to do this. So let me just get another point just to make sure. And that's kind of, I'm illustrating not just this particular incident, but in general this type of problem. If you feel like you have a complete idea and you know the shape of the function, well then just go ahead and connect. But if you're unsure, we'll get another point or two. See what comes out of that. So I'm going to do h of negative 1 here. Negative 1. F of negative 1 plus g of negative 1. F of negative 1 seems to be negative 3 from the graph there. Right here. G of negative 1, if I plug into the graph, or to the equation rather, would be 0. So now, it looks like I'm just going to have a parabola over here. Now, if I'm not sure, I'm not going to go through the whole thing because you're watching a video and I don't want to take forever. If I'm not sure about what happens over here, I could just try a couple more inputs, and that's fine. There's no reason not to do that. Always just kind of be willing to, I'm not sure, so let me try a couple more points here. Now this says also to solve the equation h of x equals 1. And then it says either show your work algebraically and show the solution graphically. So graphically I can just see that there should be a point right here and then somewhere also over here. Now the algebraic showing here would be, okay, I should just plug in, and I'll do one of these. I'll say, all right, I need h of 1, or sorry, I need h of x to equal 1. And so that means that f of x plus g of x should equal 1. Well, f of x is this function, and that might be a little bit tricky, but I know basically from looking at this thing that it looks like my solution is, you know, approximately positive 1 here, and then maybe negative 2 or 3. And so I can just kind of experiment here and justify by plugging in. Okay, if I plug in positive 1, that's going to give me 4. And then, okay, yeah, it looks like, yes, f of positive 1 is negative 3. 4 plus negative 3 is, in fact, 1. So that works. And then I would do the same thing over here. I would plug in, okay, so let's say, I'm not sure, is it negative 2 or is it negative 3? So I plug in negative 2. And that's going to be 0 over here, so that doesn't seem right. On the equation, negative 2 times 2 plus 2 is going to give me negative 2, so no, that's not quite right. Try the negative 3, and that's going to be negative 6 plus 2, which is negative 4. And then I look on the graph here, so here's negative 1, negative 2, negative 3. Yeah, that seems right. 5 plus the negative 4. So yeah, that seems correct. So my solutions would be, and I am just approximating from the graph a little bit there, but I think it's clear enough. We're going to say x is going to be positive 1 and negative 3. Now part C, this one definitely gets ugly because we have division, but it's going to be really the same process of just point by point, plug in an x to g, plug in an x to f, and see what you get out. So I'm going to scroll this just a little bit and give ourselves some room here. So we have f of x divided by g of x. Is that right? Nope. We have g of x divided by f of x. So the first thing that I notice here is that f of x is in the denominator. And anytime f of x is 0, I'm going to have difficulties. Something interesting is going to happen. I'm going to be undefined. So I know that f of 2 equals 0 and f of negative 2 equals 0. So both of those values I'm interested in. And what I want to know is, well, what is g? What happens to g at those values? G of 2 is 6. Just plugging it into the equation. G of negative 2 is negative 2. So I'm going to have 6, let's say, wait, what did we call this? Is this function k? Yeah, k. So k of negative 2 is going to equal negative 2 over 0, and k of 2 is going to equal 6 over 0. In each case, the denominator is 0, and there's two outcomes when the denominator is 0, a whole or a vertical asymptote. And it's only a whole if you can cancel it out, which implies that both the numerator and the denominator are 0 at that point. That doesn't happen here. So I know that I have a vertical asymptote at both 2 and negative 2. Oops. And now the question is, well, what happens out here? What happens in here? What happens in here? And all I can do is just plug in some points. I'll do a few, but not the whole thing. Let's say I want to know k of 0. That seems like a reasonable one to start with. Well, g of 0 is 2. Just plug into the equation. And look at the graph. F of 0 is negative 4. So this is negative 1/2. Somewhere right in there. Let's do k of 1. It's going to be 4 by plugging into the equation, and negative 3. So, well, nothing really more to write there. It's just negative 4/3, which is right about there. And let's do k of negative 1. Plug into the equation, and we're going to get 0, right? Look at the graph, and we have negative 3. But overall, 0. And now, because I know I have to follow my vertical asymptotes, I know that this graph is going to do this. Now, if you're like, well, how do I know that it doesn't turn around and come back down here? Well, plug in another point if you're not sure. Or how do I know it doesn't turn around and come back up here? Plug in another point if you're not sure. And then you're going to do the same thing and get a picture on the outside of each of these. So just plug in some x values, get the y's, and plot them, same as we did here. I'm not going to do the whole thing. And you should get something, I believe, that looks roughly like this. Okay. Yours doesn't have to be perfect. Mine isn't. It's just a sketch. But we want the basic shape there. Now, the next part of the question says, state the domain. Well, my domain, I already know. And after that, it says classify our discontinuities. I already know the answer to both of those questions by graphing. My domain is everything except for negative 2 and positive 2. And those are both infinite discontinuities or vertical asymptotes. Either name is fine. So that's nice. I already know all that. Again, how did I get these pieces on the side? I would plug in a few more points to do that. And then lastly, for this problem, we need to worry about our composition, f of g of x. So we'll do that over here. Clear out some of this stuff. So for f of g of x, I can view this two different ways, and they're equally. I can either say that g is inside of f, which it is, so it's going to, g is going to horizontally transform f. Or I can say that f is outside of g, which it is, so f is going to vertically transform g. Those are both equally valid things. They're both true. It's all about which one is easier for me to actually use. And because in this case I have the equation for g of x, but not the equation for f of x, it's going to be easier for me to say that g horizontally transforms f. And how does it do that? Well, it shifts left 2, then horizontally compress by a factor of 2. Remember, it's inside. G is inside, so it's horizontal, and it does the opposite of what it looks like and in the opposite order. So it looks like add 2, but really I should subtract 2. It looks like multiply by 2, but really I should divide by 2. And order of operations says multiply, then add. We say, no, not now. Subtract, then divide. So I just take every single point on here, or at least enough, and I do that. So if I start here and then I go left 2, so from here, left 2, then divide by 2. Now my new point is -1. And we're just going to do that for every single point. I'll do just a few more. Left 2, then divide by 2. Well, 0 divided by 2 is just 0, so that's cool. Sorry, this point here, I don't want. It's not letting me erase. I don't want that point. Pick another point. Left 2, then divide by 2. So we're at -2, now we go to -4, then I divide that by 2, and I'm back to actually where I started. And that's really, reasonably enough to graph this thing. I can just see, okay, the whole parabola is going to be shifted left 2 and then horizontally compressed. So I'm going to get a parabola that looks, something like this. Okay. And I've already described my transformation, so I've got that part done as well. Now the last two things that it asks us to do is to find m of 1 and then find g inverse of 7. So because m of x is equal to f of g of x, I just need to work out that composition. And we're doing this for m of 1, so that's f of g of 1. Well, from the function, or from the equation, I know that g of 1 is 4. So this then turns into f of 4, which from the graph, I'm just going to have to approximate because it does unfortunately go off the graph a little bit here. I think right here's 4, and so we're a little bit off that. So looks like maybe we're going to be at like a 12-ish there. I'll accept an approximation in this case since it's off the graph. And then we want g inverse of 7. Well, remember, if the input on the inverse is 7, that means that the output on the original is 7. So I'm really just saying, where is g of x equal to 7? And g of x I know is 2x plus 2, so I just solve that, and I get x equals 5 over 2, 5. And that's my answer here. Last one, I know this video got a little bit long. We're looking to decompose our function. The functions have already been smashed together, one inside the other. So what are the two choices? The most obvious one is to just say, oh, hey, I've got a root x plus 2 here and here, so it looks like that's been shoved in for the x. So it looks like the inside function, g of x, is root x plus 2, and the outside function is 2x cubed minus x squared. Because if I took this and I shoved it in for this x and for this x, this is the equation I would get.